This is a continuation of section 4.4 exercises. Problem 4, solve the following logarithmic equation. Let's use log properties here to rewrite the right-hand side as a single logarithm. We have the log of the difference, so we will write the left-hand side, log of x minus 3, and the right-hand side we will compress to be the log of the quotient, so 7x minus 23 divided by x plus 1. Now we can use a property of logarithms that simply says if the log of a is equal to the log of b, then a must be equal to b. Otherwise, the equation wouldn't be true. So we can now conclude that x minus 3 must be equal to 7x minus 23, all divided by x plus 1. Now we have an algebra problem. We have to solve for x. So we'll solve for x. We'll multiply both sides by x plus 1, x minus 3 times x plus 1. And this quotient times x plus 1 just yields the numerator, 7x minus 23. We'll multiply out the left-hand side, giving us x squared minus 2x minus 3. Rewrite the right-hand side. And we'll gather all terms to the same side and prepare to factor, since we have a quadratic equation. X squared minus 9x plus 20 is equal to 0. And that factors very nicely. X minus 4 times x minus 5. So that generates us two solutions. From x minus 4 equals 0, we get x equals 4. And where x minus 5 is equal to 0, that gives us x equals 5. And here both answers check. Always check your answers when you solve logarithmic equations. Here are both of them check. Let's move on to problem number 5. Problem 5a. We have an exponential function in this application problem, and r given as a percent is the risk of having a car accident. And x is going to be the blood alcohol concentration. Okay. So we are asked to find what blood alcohol concentration. So find x given that the percent r is 7, or 7%. So find the blood alcohol concentration that gives the risk of 7%. So in our equation, we set r to be 7. So 7 is equal to 6e to the 12.77x. And now we need to solve that equation for x. First, we'll isolate the exponential. Writing 7/6 is e to the 12.77x. And now to get the x down on the ground where we can access it, we will take the log of both sides. Here I'm choosing to use natural log since we have the e exponential. And now we can use on the right-hand side our log properties. So we have the log of 7/6 is equal to 12.77x times the natural log of e. And the natural log of e is 1. So dividing both sides by 12.77 will give us our solution for x. And we need to convert that into a decimal. And when we do the arithmetic there, we get 0.01, meaning that for a blood alcohol level of 0.01, we will then have a 7% risk of a car accident. Problem 5b. How much time to the nearest tenth of a year will it take $1,000 to grow to $3,600 if you're going to earn 8% annual interest and get quarterly compounding? So first we'll write our compound interest formula and then identify the pieces and put in our values. A is the amount in the future, and that will be 3,600. P is the amount that you begin with, that's 1,000. R is your interest rate as decimal, 0.08. And n is number of compounding periods in 1 year, and quarterly means 4, and then the power will be 4, and t is what we wish to find. So we have an exponential equation we need to solve. First, we'll isolate that exponential. Dividing both sides by 1,000 will give us 3.6 is equal to 1 plus 0.02 raised to the 4t. Okay, so let's rewrite that quickly as 1.02 raised to the 4t. To access the t and get it isolated, we will use logarithms. So we'll take the log of the left side, log of 3.6, log of the right side, 1.02 raised to the 4t. Now use our power property on the right-hand side. Log of 3.6 is equal to 4t times the log of 1.02. And dividing by 4 and log of 1.02 will give us our exact answer, which we then need to convert to decimal. So we'll put that into the calculator, and we get approximately 16.2 years. So under 8% interest and quarterly compounding, it'll take a little over 16 years to make the $1,000 grow to $3,600. And that's the conclusion of section 4.4 exercises.